So I want to start with this quote. Um, this is from Mark Andreessen from Andreessen and Horowitz, which is a very well-known venture capitalist organization in Silicon Valley. Mark Andreessen is famous for saying the quote, "Software is eating the world." And this is taken from that same Wall Street Journal article where he said that quote. And I just want to point out that this says companies in every industry need to assume that a software revolution is coming. This includes even industries that are software based today. Great incumbent software companies like Oracle and Microsoft are increasingly threatened with irrelevance by new software offerings like Salesforce and Android. And this was said 10 years ago, right? So even the tech giants are under constant threat of disruption. So during his tenure at Goldman Sachs, CEO Lloyd Blankfein used to like to say that Goldman Sachs was a tech company now. And indeed, in 2016, Goldman already employed more software engineers than Facebook, 9,000 of their 30,000 employees globally. And that was 6 years ago. So every industry has been facing disruption from the digital revolution for nearly 30 years. And that disruptive trend has continued unbroken, launching companies that embrace the trend into the future and decimating those who fail to heed Andreessen's warning, right? So that's already where we were. And then last year was pretty tough in many, many ways. The pandemic forced us all to change very rapidly. Every company on the planet found itself scrambling to reorganize, to accommodate nearly 100% remote workforce. Meetings needed to be 100% virtual. Data centers had to be retooled to allow for secure access from home computers. It suddenly became incredibly clear to CEOs all over the planet that now is a time to innovate or be crushed by the weight of history. So as a result of all this rush to digitize everything, an already large interest in Agile increased dramatically. I myself, along with all of the technology, product, and leadership coaches and consultants that I know, we're suddenly found ourselves inundated with requests to help companies implement Agile strategies as quickly as possible. Just briefly, at Startup Patterns, we provide coaching programs for technical teams and their leaders to help them navigate these challenges. And I'll tell you a little bit more about us just briefly at the end. But right now, let's look at what is Agile? Where did it come from? And how can it help companies that do not see themselves necessarily as tech companies, right? Well, it all goes back to Frederick Winslow Taylor, who is largely responsible for the way that you probably and almost everyone you know in a corporate management role see and understand work, teams, and leadership. His impact on global corporate culture is immeasurably large and yet largely invisible. And frankly, I'm going to show you how it's Taylor who is standing in the way of a lot of our innovation efforts today. In the beginning of the 19th century, the United States was largely still an agricultural economy. From the end of the Civil War, which was in 1865, to the beginning of the 20th century, the share of the population in urban areas more than doubled, from 20% to over 40%. This was the second industrial revolution, with industry increasing all over the world and people moving from rural areas into the cities. This was the world that Frederick Winslow Taylor grew up in. He was born in Philadelphia in Pennsylvania in 1854, and his father was a successful lawyer who made a fortune in real estate, and certainly expected his son Taylor to also be a lawyer. And Taylor passed the Harvard Law School entrance exams with flying colors and totally could have gone to law school. But surprising everyone, he took a very different path and opted instead to become an apprentice machinist at Midvale Steel in 1878 when he was 24. The company was owned and operated by friends of his parents. He was fascinated by the world of industry and mechanisms, and he quickly climbed the ranks from apprentice to journeyman and then foreman, and eventually became the chief engineer. During this period, the United States was growing steadily as an industrial power and starting to compete with the former European colonial powers on the world market. And there were frequent calls from Washington, D.C. to improve production capacity across industries. Historically, all the knowledge for manufacturing was held by the guild system, which were artisan craftsmen who were masters, and then they had journeymen and apprentices who learned from them. And the masters all tended to do things in their own way. Taylor became obsessed with the idea that these work methods should and could become standardized and used the same way across industries. And he pursued this goal of standardization with ruthless determination. In 1898, with 20 years of experience in machining under his belt, Taylor joined Bethlehem Steel to solve an expensive machine capacity problem. And it was there that he developed his now famous principles of scientific management. Scientific management is popularly associated with his time and motion studies, which basically broke down each step in a process so that it could be measured and optimized in isolation in order to increase the overall output of that process. But the more far-reaching impact of Taylor's work, which is less appreciated and understood, is that he separated thinking from doing and created a whole class of clerks who performed all of the planning and thinking work and left the doing to the laborers. Those clerks eventually evolved into today's managers. So in fact, the principles of scientific management was so successful in increasing output that Taylor's methods deeply influenced the first consulting company, McKinsey, which then spun off all of the other major consulting companies over time. It made its way into Harvard Business School's management theories and what they taught, and even government policy. Taylor's organization principles became the de facto standard for industrial companies worldwide. And it worked. Mass production enabled the US to compete with increasing effectiveness. Taylor had collaborated with Henry Ford and influenced the adoption of the assembly line. Using his methods, managers devised ever more sophisticated ways of monitoring and measuring the performance of employees. And even the unions, who were fiercely opposed to scientific management initially, gradually found that it enabled them to more easily define rank and seniority and job descriptions to help them solidify collective bargaining agreements with employers. So now everyone was on board with scientific management. While he died in 1915, his methods were instrumental in helping US manufacturers meet the production challenges of the First World War. There was just one problem. Quality was not accounted for until the inspection phase at the end of production. So errors in any process upstream could produce massive amounts of waste downstream. Now, this wasn't really a big deal in the first half of the 20th century as the US became the factory to the world market. But in the post-war period, increasing competition with Japan and Germany started to make quality a critical problem to be solved in the US. Now we're just going to take a step backwards in time again a little bit. Meanwhile, a little-known statistician in the Department of Agriculture would later revolutionize the way that production was done and pave the way for Agile. William Edwards Deming was born in Sioux City, Iowa, and he was 15 years old when Taylor died. His parents were well educated and instilled the value of an education in him, and he became a statistician. When he was 27 years old, working at the Department of Agriculture, the director of the department introduced Deming to Dr. Walter Schuhart of Bell Laboratories, where he then worked under Schuhart for nearly a decade. Together, they developed statistical sampling methods that are now common in manufacturing, particularly in Lean and Six Sigma. Schuhart tended to be lost in his own thoughts and made things more complicated than they needed to be. So Deming got really good at learning how to simplify and popularize the ideas that they worked on together. Deming spent the rest of his career developing those ideas and teaching them to any executive who would listen. Among those ideas was the first approach to an iterative, cyclical quality control process called the PDCA, Plan, Do, Check, and Act, which ultimately found its way into the first into the Toyota production system in what we now think of as Lean, and later into the heart of Agile. Deming's participation in the 1940 census, applying the statistical sampling methods that he and Schuhart had pioneered, was so successful that he was asked to be part of a 5-person team during World War II and tasked with improving quality in the production for the war effort. His approach to improving quality was radical, and it turned Taylor's ideas upside down. Deming insisted on bringing thinking and doing back together into the worker. He was a champion for moving the authority and responsibility for process improvement back down to the workers on the assembly line, who he felt were best suited to make the best improvements. And it was wildly successful. Unfortunately, Deming's methods fell out of favor after the war in the US as industrial giants just returned to their old Taylorist approaches to wasteful mass production now that the war was over and they had virtually no competition. But catapulting from his success in the war planning team, Deming was asked to help Japan's Union of Scientists and Engineers rebuild Japanese industry from scratch. And it was here that Deming really put his ideas to the test. In 1951, Japan honored him by creating the Deming Prize for quality, which is still awarded annually to this day. Deming is said to be the most influential non-Japanese person in the creation of modern Japanese industry. One member of the Union of Scientists and Engineers who took an interest in Deming's work was Taiichi Ohno, chief engineer at Toyota Motor Company. Ohno later went on to develop the now famous Toyota production system. Although Ohno and other executives visited the United States in the 50s and toured Ford Motor Company manufacturing plants and others, they were not going to be able to produce cars like the Americans. And the main reason was because storage space was at a premium in Japan, and they could not afford to keep large amounts of inventory lying around. So they concentrated instead on reducing waste through continuous improvement. And symbolized by that PDCA cycle that Deming taught, continuous improvement was adopted as one of the 2 pillars of the Toyota way. Another principle that Deming championed passionately, which we just talked about, respecting people by honoring the worker's own ingenuity in solving production problems, became the 2nd pillar of the Toyota way. Continuous improvement and respect for people. This commitment to moving respect and authority and empowerment to the workers on the line was in direct opposition to Taylor's more cynical and suspicious view of workers. And it's this commitment that allowed the Japanese manufacturing to threaten the once mighty US auto industry. Back home in the US, despite his preeminence in Japan, executives continued to ignore Deming for decades, right up until the late 1980s, when the threat of Japanese imports reached its zenith. Only then did American industrialists begin to take notice of Deming's work. Lean manufacturing was a term coined by Tom Krafchick in a 1988 paper for Sloan Management Review as a way to describe the Toyota production system and other Japanese methods that he was observing. Many executives associate lean with Six Sigma, but the two are not the same. Six Sigma was also inspired by Japanese manufacturing, but was developed at Motorola in the 1980s. And it lacks the critical human element of lean, the pillar of respecting people, and instead focuses primarily on driving quality from the reduction of variation from the system. For this reason, Six Sigma was never able to produce the same outcomes achieved by Toyota. Spurred by fiercely competitive CEO of General Electric, Jack Welch, in the 1990s, he pursued a ruthless approach to reorganization and improvement. And to this day, in many ways, GE still struggles to improve, though they may finally get there now that their latest CEO is actually a Toyota-trained executive. So the tragedy of the Second World War paradoxically created two important things: the opportunity for the Toyota way of respecting people and continuous improvement. It also created the information technology revolution. The craft of software development originates from military infrastructure needed to break codes during World War II. But it really came into its own in the 1960s and 70s, growing up out of corporate finance and accounting departments. By the 80s and 90s, when US manufacturers were finally desperate enough to begin implementing lean in their factories, something of the opposite was occurring in corporate IT. Big, complicated IT projects were being subjected to ever more strenuous efforts to exert control over software development using a phased gate, fixed cost, fixed scope, and fixed budget approach that software developers now derisively refer to as waterfall. Waterfall was for software development what Six Sigma was for production. All of the process and none of the heart. In 1995, the Standish Group, a prominent consulting agency, released its now famous Chaos Report, which found that the vast majority of software projects across all industries were failing. If they were delivered at all, which was not the majority, they were delivered way over budget and well past their deadline. This was a clarion call to the software world. And in response to this damning evidence about corporate IT projects being mishandled, a small group of software innovators were quietly developing a whole new method inspired by the very lean manufacturing efforts that were underway in the factory. Kent Beck, Ken Schwaber, and Jeff Sutherland, to name a few, had been inspired by what was going on in Japanese manufacturing. Beck is now known for being the creator of the Agile method extreme programming, while the other two, Jeff and Ken, developed the method now known as Scrum. All three were among the signatories on the Agile Manifesto in 2001. The idea of Agile was deceptively simple. The two pillars of respecting people and continuous improvement could be applied to software development as well, not just manufacturing. The first of the four principles of the Agile Manifesto, as you can see, individuals and interactions over processes and tools, reflects respecting people. And the other three reflect continuous improvement. So where Agile failed to take hold, there's usually a pattern of companies embracing all of the prescriptive, process-driven aspects of Agile, the daily Scrum, sprints, and so forth, without any of the more human aspects. Senior leadership demands that everyone embraces Agile, but sometimes they themselves aren't quite ready to change. And Taylor steps forward to haunt us with his separation of thinking from doing. Among the main limitations of Taylor's thinking, and where Deming and Ono and others who followed in their footsteps differ, is in trying to control things in an uncertain environment. The power of the PDCA cycle, and any continuous improvement feedback loop for that matter, is that it doesn't try to predict the future. Agile, like Lean, is about embracing change. And Agile requires a type of mindset that also embraces change. It requires a mindful Agile leadership. 3 books published in the last 2 decades, for me, have provided the final pieces of the Agile mindset puzzle. First, in 2005, Stanford professor of psychology Carol Dweck published Mindset, The New Psychology of Success. In it, Dweck explains that there are 2 main types of mindsets, fixed and growth, and that people can actually learn how to change from one to the other. A person with a fixed mindset believes that everyone has relatively fixed qualities that will change very little throughout their lives. You kind of get what you get. Fixed mindset people tend to struggle with failure because they see it as a reflection of their relatively permanent attributes. A person with a growth mindset, on the other hand, believes that people are capable of learning and growing from their mistakes. They embrace experimentation and failure as a learning opportunity. We can see Dweck's research reinforcing the core idea in Agile of continuous improvement. If we embrace a growth mindset, it means that we can embrace our mistakes as opportunities to learn. And this is in direct alignment with the principles of the Toyota Way and the teachings of Deming. A few years later, Dan Pink published his book, Drive, The Surprising Truth About What Motivates Us, in which he explained that in today's knowledge economy, teams and individuals must be motivated by 3 central concepts of autonomy, mastery, and purpose. Like Deming, Pink illustrates why teams must be given control over their time, their tools, their tasks, and their techniques if we want them to produce positive outcomes for the business. They must have the ability to learn and grow and become masters of their craft. And most importantly, they must be guided by a clear sense of purpose. Pink's work supports the idea of a mindful Agile leader by encouraging us to delegate and let go of control. Allow the teams to guide the process of continuous improvement. And finally, in 2011, Thinking Fast and Slow was published by Nobel Prize winning economist Daniel Kahneman. His work showed how extensively cognitive biases affect human behavior. He identified 2 different systems in the mind. The first, a fast and automatic pattern matching machine that we use to make snap judgments under pressure, and was likely inherited from our prehistoric ancestors. The system works by leveraging biases that we've developed from experience so that we don't have to decide a shadow in the grass is a snake every time we see one. There's a shadow and we just jump out of the way. The second, a slower, more methodical system we use to deliberate and calculate and make more rational decisions. The trouble with this is that most humans operate from system 1 most of the time. System 2 takes effort and focus and concentration, as well as calories, sleep, and relatively low levels of stress in order to function properly. So under pressure and overworked and malnourished, we're more likely to resort to the snap judgments of system 1, even though they can frequently be wrong. Those judgments are clouded by a range of cognitive biases, and those biases, while appropriate for immediate physical danger, are not appropriate for making rational decisions based in the workplace. The mindful Agile leader is aware of the 2 systems operating in their mind, and they take responsibility for making sure that they're thinking carefully when the situation calls for it. Further, they encourage a growth mindset and autonomy, mastery, and purpose in their organizations. Agile teams can be incredibly effective and efficient, but only if we follow the core precepts of Deming and Ono of respecting people and continuous improvement. Respecting people means giving them as much autonomy over their work environment as possible and trusting them to do what's right. Continuous improvement means making sure that our organizations embrace an experimental growth mindset, that learning is encouraged and mistakes are not only tolerated, but embraced as learning opportunities. The 20th century has already presented us with some pretty formidable challenges to our thinking and our ways of business. Relying on antiquated methods of Frederick Winslow Taylor and Henry Ford, both have been dead now for nearly a century, is as inappropriate as insisting we all travel by steamship and send messages by telegram. The world has moved on, and so too should our management philosophy and leadership culture. Agile's here, and it's time to embrace it. We can all be mindful Agile leaders.